In this video, we are going to find the absolute maxima or minima of this function f of x equals x to the fourth divided by e to the x on the domain 0 to infinity. So to find the absolute maxima or minima, we need to look at the first derivative. So the first derivative of this function is, let's see, the derivative of the numerator, 4x cubed times the denominator, e to the x, minus the numerator, x to the fourth, times the denominator, e to the x, times the derivative of the denominator, sorry, all divided by e to the 2x, which of course is equal to 4x cubed minus x to the fourth divided by e to the x. We are going to find the critical numbers for this function, so we ask ourselves, is the derivative defined everywhere? And it is. And we set the derivative equal to 0. So that's 0 equals 4x cubed minus x to the fourth divided by e to the x. Multiply both sides by e to the x, and we get 0 equals 4x cubed minus x to the fourth, which is equal to x cubed times 4 minus x. So there are critical numbers at x equals 0 and x equals 4. But of course, x equals 0 is not in the domain, so we don't care about that particular function. And now we are going to ask ourselves, I'll draw a number line. The left-hand side of the number line will be 0. We have a critical number at 4. So we want to know whether the first derivative of this function is positive or negative. Let's start between 0 and 4. So let's say the number 1. So that would be, if we plug number 1 into the first derivative, we get 4 minus 1 divided by e to the 1. So that's positive. 4 minus 1 is 3 divided by e to the 1, which is positive. And then if we plug a very large number into this function, bigger than 4, we end up with 4x cubed minus x to the fourth. That will be dominated by x to the fourth. E to the x is always positive, so that is going to be negative. So the first derivative test, we've got a function which is increasing up to 4 and then decreasing from 4. The first derivative test would say that we have a relative max when x equals 4. And of course, since this is our domain, the function's only increasing up to 4, so everything between 0 and 4, all function values between 0 and 4 are less than f of 4. And again, above 4, the function is only decreasing, so all function values above 4 are going to be less than f of 4, so we have an absolute max. An absolute maximum at x equals 4, and that would be f of 4. The absolute maximum is 4 to the power 4 divided by e to the power 4. Let's see, 4 to the power 4 is 256 divided by e to the 4. So that is our absolute maximum. We do have to ask the question, do we have an absolute minimum? Well, let's see. F of x, as x gets smaller, so we're going to look at the limit. As x goes to 0, x to the fourth over e to the x. Well, e to the x is going to head towards 1, x to the fourth is going to head towards 0, so that's going to be 0. But of course, we never achieve 0. We just get as close to it as we want to. And then let's look at the limit as x goes to 0, or x goes to infinity, sorry. As x goes to infinity, x to the fourth over e to the x. And here again, e to the x, this is going to be infinity over infinity, but the e to the x is going to go to infinity faster, so I would expect this to go to 0 as well. Again, the function is decreasing, so the function should get smaller. It never changes sign. This is always positive. But again, we're never going to achieve 0. F of x is never actually equal to 0. So again, we have an absolute maximum, but we don't have no absolute minimum, because the function never actually takes the value 0. The function is always greater than or equal to 0. It's actually always greater than 0, sorry, but the function never achieves that value.